Oh, I should change my titles, right? Um, all right. So I might have new ideas. I'll have to see if it works though. The song is a banger. Alright, I was trying something else off stream. What is this? Oh, they can accrue. But I don't think it's gonna work. So I'll just get rid of this. So I got a new idea. It probably works up to a point. So the coordinate system, what does it do? And I think the answer is you're trying to know where you are relative to the origin of the world. So a good coordinate system tells you where you are relative to the origin. So let's try to work with that in mind. Is the music too loud? Kind of. Okay. So I think this is the 0. Well, rather it is because I just drew it. I guess I just care about one side for now. So my new idea is So like um, numbers have a range. So for example, integers have like from minus 4 billion to 4 billion, if I remember. Minus 2 billion. Okay, so yeah. Let's just copy that in here. Oops. Okay. So that's my range. If I want to have something outside, I had started drawing that right last time. Here. Where you have like 1, 0, 1. So the goal is to have numbers that stay within this range. Coordinate. Right now I coded it like this, where you have x, y exponent. That's fine. And then I think I add something else. But then you require something else. And then I don't need the... I want to get rid of this parent thing. I'm getting new ideas as I'm writing the code. Damn, this is sick though. I can't wait to have this working. Wait, he has... That's so funny. Alright, whatever. Okay, I need to name... I'm naming variables. Oh, also... Give me 1 sec, I'll be right back. I kind of want to learn this song. Nando demo sake. All right. So what is this? You need like a few parts, right? Okay, how do I visualize what I'm trying to do? time to go. How do I draw what I'm trying to draw? Dang. Ah, it's so hard. Well, it's not that hard, but it's like, because I don't have my thing yet, I don't know where to put my nose because it's gonna feel crowded so fast. I need like this infinite, like I want to just zoom in here and start drawing. All right. Okay, ignore the origin. Okay, I have this. Okay. I'll just call this 0. And then I'll have blue is fine, I guess. I'm not really sure what I'm doing. So this would be like, let's say 0, 1. Okay. I don't care about like the specifics for now. Let's just do like oops. That's funny. Alright. So this you can do all the way up to like the 2 million. And be able to know like this one. So it's like a grid, I guess, right? Where the numbers here are from like -2 billion to 2 billion. Oh, did I do them like that? Did it glitch or did I draw them small like that? Oh, whatever. What was the hotkey again for scrolling? Ah, man, I can't remember now. It's such an obvious hotkey too. Control middle. Oh, it's a middle click. Ah, like that. Right. This feels so powerful. Man, I can't wait for this to become unbounded. Dang. Yeah, this is like you can just draw in, zoom out, draw like this, zoom out a little bit, or zoom in. Yeah, this is feeling so fast. Oh yeah, there's also this, the hyper zoom. Let's listen to their other songs. Did they remove? So how do I call this? XY. So the so wait. This is float. For now it's float, eventually it becomes int. XY exponent. And then I need like this thing. What is it called? Do I just call it like XX? YY? Just be lazy. And then it defaults to like 0. And then let's say you run out of range. Zero, 1, 2, and then you end up, you need like some number that is bigger than those. You would be able to point, but then it becomes recursive, doesn't it? Coordinate parent. So this is not required now. Yeah, I'll start with just this for now. I was not using it? Like I was. This was not used, right? Okay, it wasn't. This is J-pop, right? Yeah. I assume. What is this one? Music to refine. Eight hours of perfect focus. Cool idea. Okay. And then the goal would be to have only the need of one single camera to navigate in this system. Okay, chord. XY exponent XXYY. Okay, with this, I guess I should code like comparison. Man, I forgot how. You need like to be able to say, is this bigger? Is this smaller? I guess you also need math. Like one coordinate plus another coordinate. This is hard. Man. Also, so you need this, and then there's also another part right after that's required, I guess, if I want to have true infinity. Because these numbers also have a limit. Okay, let's just do it right away then. This is int. Oops. All right. Let's just do it right away. All right. So I have these. Actually, should I just start with no? Then add the math. Do like the simpler math first and then add these after? Maybe not. I can just assume there's 0 for now. Okay, so I must have coded something like that in the past. Where would it be? I can look at the code over there. Let's look at... I'll just base it on this. Okay. Operators. There's the add. Do they have equals length? Wrong. Subtract. This define custom. Oh, I guess my music is wrong now. So I can, so those are the operators. Okay, good. So what did you do? Custom value, T custom, T value. Let's try this. Public bool. So it doesn't like that. Oh. Now it's happy. Okay, interesting. I'll need a better name too for this, probably. So how do I know if a value is smaller than another value? Step one is you should check the exponent, right? If the exponent is the same, okay, wait, let's try this. I'll probably have to rewrite this many times before I understand. If a dot exponent equals b dot exponent, so that means the numbers are on the same scale. So if they're the same, then you have to check. But then, wait, that doesn't make sense, does it? Because this is a 2D number. Does it mean that I need to do it on 1D first? And then I can do like a vector after that using the 1D numbers. That is interesting, right? Solve it for 1D. Eliminate all the things that are not required. Yes. That does simplify the math. Instead of working in 2D. That has to be a good idea, right? Let's just get rid of this for now. Or I need these, right? Okay. Start with 1D. So if the exponent is the same, and then if a dot xx equal, but then x doesn't make sense anymore, but whatever. If this is equal to b dot xx, I'll fix the code after. This can be rewritten to like a one-liner pretty much, but whatever. Then you can do, so if they're the same, then you're in the same scale. Return, so a dot x b dot x else if they're the same, then a should be fine. So this covers the cases. This is hard though. How do you handle an exponent that is different? Without having to do a conversion. I'll keep it written like this. Isn't that just simple math? Okay. So exponents. By the way, looking at this code, isn't this a mistake? Because bigger is not exactly the opposite, right? Because you end up with if A is equal to B, then it's not smaller. I don't know, this looks wrong. B, if it's bigger, I think this is just wrong. I guess the way to do it would be to write some values. So if A is not equal to B, fine, I'll just return false for now. Let me just re-look at this. Okay. Red is here. Camera 1. Oh, let me just read this really fast. This is using that. In other words, I'll rewrite this really fast, even though no, never mind. Gotta stay focused. red. So 100, 110. Wait, let me read this again. Oh, I wrote it like that for true. That times exponent scaling. Right. There is this concept of exponent scaling. That's like a constant. Oops, I'm starting to become a ghost. Okay, better. I wonder if I should just recode my line drawing shader right away to use this. Then I can eliminate all the camera stuff. Okay, no, let's just focus. You have... Okay, camera 1. And then the coordinate here, those are whole numbers, integers. Okay. The thing that matters is here. Exponent value. 210. This is let me just pause right here. The value of this 4. Okay, good. The value here, this can change based on my zoom. Okay. What happens if I change that instead of 2? If I put it at 1. Okay, this is fine. Okay, those are all at the same. Okay. This is drawn here. So this is 100 by 100. 100 by 100. Okay, they're all... Okay. I'll just put some notes here. So... one of them is... 100... XP is something, and then it's 0 for the XX. Okay. So this camera 1 has exponent is 4, right? Let's say 0 instead. You're at 0. And then the other one is at 2, if I remember, or 1. So this is 0, 1, 2. 0, 1, 2. And then... so what does it mean? XP is different. So the numbers, while the X is the same, this one is a smaller number than this one, and that one is a smaller number than this one. If we were double... okay, wait. This one is smaller than this. This one is also smaller than this. Oops. If this was 200, it's the same as that. This one is an order of magnitude bigger. And then... $300 is bigger than that. So how do I compare this without having to convert? Is it even possible? Since these numbers, okay, I guess this can be converted into the higher exponent without losing value, right? Or am I crazy? We don't care about precision loss, right? At least for the comparison. In order to raise this, $200, if you increase by 1 the exponent, oh, I guess the XX. What is this? How do we call X? I mean, this conversion works if you're on 0. Oh man. I guess what I'm trying to solve. So like this works well around the origin. And then this part is supposed to handle the rest. Though even this is not good enough. So you have to project it into a different... Ah man, I can't visualize the numbers. It's so annoying. Cause there's like, I can visualize on the small scale, and then as soon as we get too big, it's like I can't wrap my mind around it. Let me see just what I did here with this math. I guess the answer is this, right? You power. So in order to project 100 times the power exponential scaling times 0. This means it's 0 power to the power of 0. Two to the power, man. 2 is 1. Right, so 100 times 1. To the power of 1. 2 to the power of 1 is 2. Okay. So in order to put these together, you do a power, right? Let's just do this. Yeah. So you do 200 times this. This one we don't need for now. This is times 1. Is there a thing as power but for whole numbers? Oh man, this is so dumb. Fine. Let me just check that. I guess I don't care. So 200. This shit gives me, this gives me 2. Which means it's wrong. Oh, but that doesn't work because this gives me a decimal number. This one would work, but it's kind of annoying, right? But it's whatever. Okay, this is the math. So else if a.x is smaller than b.xp, in order to get -1, it's this the smaller minus the bigger one. So in other words, that exponent minus b dot exponent. Then you end up with a number that's compatible with the other number, which means that should be fine, right? Else, if it's the other way, okay, and now it knows that we completed everything. Hey, maybe I give it a test to see if this is working. Once I have like those basic operators, I'll be able to create rectangles from whatever this is. Let's call this. Okay. Then what is this? X. Let's go check what they do in the C# libraries. What was the repo again for that? Was it this? Can't be, right? Runtime? Sure, let's look. Damn, I'm really rusty. Is this allowed? What would this be? It's like you're getting the grid. Is there a name in math to represent this? It's like a translation, pretty much. Oh. So they called it M value. What is the M for? I forgot. Oh, is that what I should call it? Power. Bum, 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 bum. Hey, THC, welcome. Boom, boom. Okay, it's whatever. Just name it whatever. We'll just call it an A value. Kind of, maybe. They're still a part of the map, and I just don't like these. Can I just call it V? And then what is this? Hey, do you know if there's a name in math where you have like a grid? Like let's say you have numbers here and then you're running out of numbers. Here, I guess. So then you increase like whatever this is, 0, 1, 2. So you're saying like you're not in the first one. You're in the second one. And then if you want to use a value further up, you're not in the second one, you're in the third one. What is this 0, 1, 2? Is there a name for this? How would I call this? Man, naming things is the harder part of everything, isn't it? Element. Do I call it element? No. Do I just call it like skip? Skip 1, skip 2? Fine. It's not accurate. It's not like the right math name, but it's just a skip. I'm skipping how many? I'm skipping 0, I'm skipping 1, I'm skipping 2. Okay, that's fine. It works. Right? The position 1 means I skipped 1 before it. And then the position 2 means I skipped 2. Alright, it works. This means how many did you skip to get back to the origin? Okay. I'll put some comments. Size of the grid. Oops. Probably makes no sense for future me, but I guess I don't care right now. Oops. Okay. So now I have something, and I have this that's working code. By the way, welcome to everyone that's new to the stream. I'm working on a drawing application where you can zoom in, draw, zoom out, draw. But as you can see, there's a limit to how far you can zoom. So I want this limit to become infinite. Oh, is that a bug? The cursor is like flickering like that. That's because it's updated at the wrong time, I guess. It's not really a bug, it's more like visual bug. Whatever, I'll think about it later. Okay, now I need to do the bigger. And there's also equal. Alright, whatever. Let's start here. I don't handle skip yet. Oh, I do, but not on both sides. Yeah, maybe before I do this, I should solve this fully. So if the exponent is different, the skip part. So if the exponent is the same, then it's a matter of the skip. And the skip is the same, it means we're in the same grid. the limit when you run out of numbers, like this number gets like to 2 billion. For the exponent, this is fine. The limit is like so high that we probably don't care. You offset, yeah. Exactly. So right now I'm like yeah, right now I'm like shifting the grid to handle numbers outside of the grid. So this limit is a lot smaller, but I think I'm able to do something clever. So there's a part of the math here that's missing that I'll add after, maybe. Unless the skip is good enough. I'm not entirely sure yet. It's still 2 billion, so whatever value is pretty much multiplied by this. Or is it? It's multiplied by the max number of this plus v. So max int plus v pretty much. I'll have to visualize it after. But I like the goal is to be able to know where a number is relative to the origin. Should I draw something here on the origin? I guess I can. U. I'll put it up here. Zero. 10 is fine. Black. Origin is there. Did I make it that big? Oh, because it's the same size as the other one. Okay, yeah, that makes sense. Oh, that's interesting. Okay, whatever. Might as well lower this down to 1F. Oh, doesn't that mean my thickness is too big? Yeah, I guess it is. Sure, you'll get 4. Okay. Skip. What do we do with skip? So if the exponent is the same and the skip is the same, it means the numbers are together. Otherwise, the smaller means the number is smaller. So, since they're like on the same scale. If the exponent is different, in other words, A is smaller than B. Let's do this. Hey, salut. $200, 0, 0. 200. So if the skip is 1, But one, oh man, this is a huge number though. Oops. This is where my brain breaks. How do you handle this? This is like 200 plus 2 billion. How do I do math with that? I'm able to project this up into the higher scale, right? In other words, should I do math on the max int? So if A, so 0, eventually I wonder if I can get rid of this math, but whatever. Okay, A, it's AV plus something to offset it by the number. You offset it by skip. This is fine. In other words, okay, that times 0.5. Oh, okay, they put. Oh, that's not annoying. Fuckers. Is there a way to like not have exponential numbers? Oh. Thousand, millions, 1 billion, which is correct. Oh, wait, that's an issue, right? The skip can end up outside the range of the higher dimension number. And also the higher number might even have a skip itself. How do you do math then? Oh, also this didn't work. It's not even the right code. This is pretty much that times. Okay, can I like just do math? Can I do the skip separately then? This is like if you don't like that, why? My bad. Oh, in other words, skip. I can bring skip into the higher dimension without having to use the bigger numbers, right? I think I can by doing the same math as this. In other words, I don't have to check for 0, right? A skip. So I put the smaller into the bigger. Doesn't this work? Then I can do if. Then I can do this. And smaller to. Something like that. Does it work? So let's say the number is 1. Or first 0. If the number is 0, then it's just 0. You compare the numbers. If the skips are different, then you're somewhere else, right? Yeah. Okay, 1 times. Oops. Then you're at 0, therefore you can compare. I mean, it's not complete, is it? Well, also, I guess this should be like extracted to be for both. Because this is not related to this, right? Oh yeah, it is because of this. You want to get into the... Okay, fine. Is it the case where I do the opposite? Bring B into A? So let's say 1 minus 0, 1, 2 to the power of 1, 2. So let's say the skip is 1 times 2, you end up with 2. the B number. That doesn't seem to be working. If the skip is different. What am I trying to do? Okay, if the exponential is smaller, you take, so the number is 0 right now, 1 rather. One means you're like at like 2,200,000,000 or whatever. And then you're comparing it to this one, which is like way smaller. So this one skip is 0. So that means 1 when I bring it to this. I mean, this would still be within, I mean, the number is bigger. Okay, 1 times 0.5 is 0.5, which is 0 because you're an int. But the 200 is no longer 200. It needs to be... So then you get AS. AS plus something. No, because it's an int, you end up with this side. AS is equal to BS. You end up with 0 here for this number, but the 200 here has to be plus this. A skip times map.pow 2f. Okay, wait, let's do this. The value is 200 times 0.5, which means 100. But you need to do plus. But that's the thing, I want to avoid doing plus of half. Because you quickly run out of numbers, right? In other words, then it's the opposite, right? You have to bring the skip from the bigger one down to the smaller one to make the math simpler. So the 0 2 to the power 0 minus 1 2 How do I know that this number here is bigger than this? Oh, isn't this 0, therefore it's smaller than 1? Is that how I know? What if the number is 2 billion though? I'm running out of juice. Ah man, wrapping my mind around like big numbers is expressed like this is kind of annoying. Like, I know at least the part that I have here works, but how do I use it? That's the issue. How do I compare this to this without like running into number issues because of the conversion? The skip number means that you end up it's possible to have a skip that runs out of the numbers on this side. Likewise this side. So how do you compare numbers that can't be compared? Like the number I end up with is this, which is way bigger than 100. But I don't want to resolve this number if possible. But does it mean it's impossible? If you don't resolve it, how do you know what you're working with? How do you work with this skip? I guess the question is, how do you compare numbers without them being on the same magnitude? Dang. Okay, I'm able to compare these. Vx, this is easy. It's just this. So it's impossible for the smaller one to end up outside the bounds of the bigger one. So you don't run out of numbers. But this one makes it possible to run out of numbers. And it is required because the bigger grid can't perfectly, without floating point numbers, it can't perfectly represent the smaller one necessarily. That's pretty easy to prove. Like this is, let's say this is 1. This is also 1. This number is 0.5 on this green grid. So you can't represent the red inside of the green grid. But you can represent 2 on the green grid. The alternative is to... No, I can't. There's no... And the skip is the distance to the origin by doing a translation of like the grid. It's whatever. How do you work with this? I can do this because A is contained within B. Let me just delete all this for now. Okay, this works. But how do I include skip on this side of the map? If the skip is large enough, we don't need to check this. But how do I know that? How do I know where I'm at? Because the numbers can't, they don't make sense depending on like how big they are. Once they become too big, they're too big. Like I can do the conversion thing, but it doesn't mean it lies on the right. This is what I don't want to do. So 0, 1, you can have an infinite amount of units within that. And if I don't want to code them using floating point numbers, like this -2 doesn't fit nicely on this grid up there. But it would fit nicely some. Hey, Finkelum. There's also the matter later. How do you generate a number? But whatever. Skip. Maybe there's a different way of thinking about this. Like, this isn't rocket science, right? It should be so easy. This doesn't look like hard. If the exponent... Oh, really? Now I'm starting to starve. I guess it is already past noon. What is this? So if the numbers are the same magnitude and they are the same skip, then I can compare them. Otherwise, compare the skip and don't worry about the smaller. Okay, so this is good. Okay. If the numbers are different exponent, I need to put the math in a way that I can compare the skips. Is it a case where I gotta write down the numbers? The issue is that unlike this smaller number right here, this can be compared because of they can be put in a relationship to compare them easily. Maybe this doesn't even work actually, because if the XP of A is smaller than XP of B, so let's say this is 0 and this is 1. Hey, Lost Boy Studios, welcome. This is probably another stream with barely any progress, but the numbers are so annoying. Did I even do this right now? I forgot if I solved this earlier. Wait, so this is 0. So this means A 200, let's say 0.5. I think that works. If the exponent is smaller, this 2 to the power of so this is 0 minus 1. How are you doing, by the way? There is a decimal part that we kind of lose. Does it matter? For now, I guess it's whatever. The numbers are like so big that it's hard to understand. How do I compare a sliding grid? Dang. Alright, that's true. Are you still doing game dev? I wonder if it's a case where you have to bring both mobile apps. Oh yeah. Yeah. Are you still on Flutter? I can project these into a higher dimension, right? And then I get number that I can compare. Is that how it works? React Native. Dang. Man. Why is this so... This is so obvious. I can't believe it. I'm gonna... Okay. Let's just draw it, I guess. Okay. 0, 1, 0, 1, 2, 3. Okay. You're there. You go all the way here. Let's just say poop. 0. With like its own little things. Whatever. I wish I had more room now. This thing is in my way. I want to get into mobile apps too. At least this app I think would be nice on tablets. Zero, 1, 2, 3. That's a unit. And 0, 1. The dev account, what does that mean? Oh, the apps. So if you have like a Google Play account, yeah. Even if the app doesn't need updates. Damn, there's so many different units. 0, 1, 2, 3. I wonder if it's hard because the skip doesn't make sense. The issue is that the skip is kind of related to this exponent above. It's expressed as like whatever little number plus the whole range. Can I express every number anyways if... Like, let's say you had v exponent. V... Like, let's say there's no v, but like you do v2 exponent 2 or whatever. But I don't think I can express every number. Like, with this I can. I can express every number up to a point within this grid. This grid size. There's still a max value, but it's... But it's kind of similar, right? The skip is similar to this V. It's like a number that's really far away. 0, 1, 2. 0, 1, 2, 3. These numbers are so big. Okay, it's obvious that this number is way bigger than this, but how do I know that? It's because I do 1, one is this. But I can't use that number because the skip can bring you into a dimension that's... How do I compare the skip between the two orders of magnitudes without converting? Oh, I'm not allowed to have 3 billion. It's outside the range of ints. It's 1 billion. Let's just do 2 billion. 2 billion works. This is smaller than this number. Oh, am I able to convert this down into a skip? In other words, 2 billion hundreds, thousand, million, billion. $2 billion. I guess this is not quite right. 1.6. So that shows me the skip. But then doing this down means that you can run out of skip space on the lower, but on the higher one you can't run out of skip space, right? One. Can't I do... Wait, 200... 1... Ah, man. Okay, focus. You have... What if I have like a skip of like 10? Can I like... this? Okay, so for these numbers, I'm converting the value into the higher one, and then I can compare them together. That's fine. And then if I do this, 1, can I convert this skip into a skip of this? Can I? Okay, wait. I said the number is this. I can't represent this number, right? Yeah, I can't. It's above the int. This should be like way easier. I guess I'm... It's not really a hard problem to solve. It's just I can't wrap my mind around it. Zero, 1, 2. When you're at 2, you end up with a skip of 1 here. A skip of 1 into this higher one is a skip of 0. A skip of 2 is a skip of 1. Skip of 3 is also a skip of 1. But a skip of 3 here is a skip of 0 up here. 0, 1, 2, 3. They're all within the skip of 0. You just write like this: 0, 1, 2. And this pattern is so obvious to all programmers, but I can't. I'm that rusty, I guess. 0, 1, 2, 3. This is like so basic. 0, 1, 2, 3, 0, 1. It's a. Is it 2? I need to feed this 0 into a function and it outputs 0. 1 into a function, it outputs 0. 2 into a function, it outputs 1. 3 outputs 1. What is this one? Is it it? It's so obvious. I can't run. 2. Okay, that looks correct. So it's the scale factor. So how do I know it's divided by 2? And then this is divided, I guess, by 4. 6 divided by 4, 1.5. So the 4, so this is 0, 1, 2. Is it this? So exponent 2 to the power, okay. 0 minus 1 to the power of, I get that, but if it's the other way, you get 2. This has to be it, right? So 1, you power it, the bigger one minus the smaller one, right? And then from 1 to this is 2. This is correct, I think. So to project a skip, isn't that what I had earlier though? Whatever. Let's just try it. AS is AS. So 1 times 1 divide by 2. So 1 divided by the bigger one minus the smaller one. And is this equivalent? Let me just check. So let's say instead, I'll use 2 because it's easier. 2 times, if it's 0 minus 2, 0.5. This avoids the division, right? Minus the bigger one. That does work. 2 times the power. Since we're projecting the smaller skip into the bigger skip, 3, 1.5, 4, 2. I think that's allowed. Okay, so instead of a division, we keep it as a multiplication with A minus B. So this is the skip of A into B. So it's impossible for the skip of this one, 3, whatever. When you get to the max number of skip, it will still fit into this bigger one or the bigger one or the big. Okay, so now I get a number that can be compared to the B skip. Oops. So this is AS. If they are equal, then I can do this. Is that correct? If the skips are equal, then you take the V of A and then you can compare these values directly, right? I'll need to try. Okay, now there's this other case. If it's the other way, B, okay. If BS, AS, these can be compared like that. Otherwise, you gotta project the number into the other dimension. Yeah, so if the skip are the same, then you can compare. Is this all? Does it work? I feel like this doesn't work. There's still a missing part. Why? Let's say you're here, 2, and then the skip is 1 on this one. Yeah. That's what I'm doing all day, simulations. Okay, so let's say you have 2, and then it's 200 with 2. So 2 becomes 1, they're comparable. And then the number is fine, right? 2, 1. Okay, let's just give it a try. I think I've gotten something that works. Let's feed in some numbers then. Oh, while I'm at it. Or are you unhappy? What? Fuckers. Zero. Okay, let's try these examples. So 100, 0, 0. 100, 0, 0. B. 100, 1, 0. If A is smaller than B, maybe I should also have a 2-string. Nah, whatever. For now it's fine. Let's just run this. See what if this at least does something that I want. Boom. Okay, that's good. It was written true here, so that's nice. Because this number is smaller than this. Let's try this. 2. This should be equal. False. Perfect. Bigger. Oh, did I do it on both sides? Oh, I don't have this supported. So I guess I don't care for this one for now. Okay. So 100. Okay, so A is smaller than B. True. What about if the skip is 1? Nice. If you're on the higher order, should still be smaller. This one is bigger. False. A is not smaller than B. So that's a bug. They are not equal. A is smaller, that's true. Oh, I guess I could just put a breakpoint here. Ah, so there was a thing to handle. Yeah, that's fine. AV is 50. But it's 50 plus the whole it's not quite correct. So it a skip times so is that correct? It's 100. This looks correct, right? Should I compute it? 32. $31. 32 minus 1. No. This is the right number, right? Minus 1. Okay. This is a different value, isn't it? 3741. This is telling me it's 8 here. .5. Oh, because I have the wrong number, don't I? This becomes 50. Okay, now this is correct. It's just because yeah. False. So A is bigger than that. So I also need this part here. Oops. BV. I'm too lazy. I'll just do it. Okay. B skip max value. B, A. So I think this is allowed. Nice. Pretty sure this is correct, but I can't visualize it in my mind. This 200. Copilot. I don't think it's good enough, Copilot. It's I tried the and it's doing some really weird logical errors. So, does it work? This first version? Yeah. I mean, good luck getting it to output this. This one should stay like that. Well, the math looks kind of annoying. Most of the time, you don't have to evaluate that. I think this is fine. And then I'm able to get the skip from the higher order number, whatever. This, but the other way, right? I can take a number here and get a skip out of it, I'm pretty sure. Or close. Anyways, let's just do this. Bigger. They should always be opposite. False, true. A is smaller, true, false. If this is 200, they should both be false. Oops, never mind. This should be 400. Now they should be equal. Perfect. And then the next part would be to have How do I start having this exponent scaling? So in other words, the exponent times something. Would this be in this? So that means the 2 here would have to be maybe I should have put that in my math from the start. Oops. Is there like a utility function for that? Guess not. Oh, true. Doing it like this is interesting because when I get into the 2D world, anyways, I should do equal to while I'm at it. Oh, there's also addition and subtraction. True. Okay, let's do equal first. You don't like that? My bad. Cool. And then the return. That looks weird, I guess. I guess because you can just return straight through. That's weird. Wait, what? A whole thing can be simplified, can't it? If A that's give equals B, then return that. Otherwise, false. Because they are not equal, therefore they're not the same. I wonder if I even cover all the cases. Yeah, whatever. We'll see if there are bugs later, maybe. I kind of don't want to debug this though. So hopefully it just works. This is also that, right? This should also be equal, right? Or not? A is bigger than B. This one should be B bigger, right? A is still bigger. Maybe my math is all wrong. I'm not sure. This one should be for sure bigger. I should end the stream. Already 3 hours. They are not equal. A is smaller. The skip of A is 1. Then B skip. A is smaller than B. Oh. Wait, was that what it was saying? This was true? Because A is smaller, so maybe it was all fine. A is smaller. True. If it's the other way... Never mind, so it was just showing the right result because A was smaller. How do I make them be equal with the skip? I guess I look at this. 0. Let's keep it at 0, that's fine. 0, 0. You're at 0. Skip of 2, skip of 1. Is this not correct? This can't be right. 2. So why is A not equal here? A is considered smaller. Now A is considered bigger. To 4 maybe. A is smaller. AS equals 1, which is correct. B skip is also 1, so they are equal. AV is -1. Let's start here. This should be 0, right? Yeah. What about this part? -1. A skip is 2 times... Oh, did I... I need parentheses, right? To multiply this first. Otherwise, I'm probably overflowing. I'll have to do the same thing elsewhere. No, it still thinks A is smaller than B. negative number. One. 2. 2 point something. Did I overflow for real? I hate this interface for the watch. Why? 2. .5. I guess this is the right number. 1.7 something. Yeah. Two times that. So by doing 2 times that, I'm back to having a number that's too big. Yeah. So the math is kind of right, but it's running out of numbers. I'll have to think about it more. I guess I'll end it here. That was too easy, I guess. Anyways, thanks for watching. This is kind of progress.